So welcome to today's session. It's been a couple of days since we discussed another topic, and today I want us to introduce another chapter which is already here, captured on this tiny board, longitudes and latitudes. So this is our next area of focus, and in this topic we are going to focus on basically a topic which you must have covered in geography or from your primary school knowledge. So this is a representation of the globe, and I want us to focus on a number of things. So from your knowledge in geography or social studies in a primary school, you must have seen this. So in this case we have the prime meridian, and this is the equator. So one thing that we need to know is that these two lines divide the earth into two equal parts. So this is basically, this globe is a representation of the planet Earth. So we have the prime meridian and the equator, both divide the earth into two equal parts. So in this topic we are going to discuss longitudes and latitudes, and this is exactly what these are, longitudes and latitudes. Besides the longitude, the prime meridian, there are other lines which run parallel to this line, both from the North Pole to the South Pole. We also have other parallel lines which run parallel to the equator, running from west to east. So the lines which run parallel to the prime meridian are called longitudes. And one thing that we need to know is that all these lines meet at the North Pole and at the South Pole. For example, if I was to come up with another longitude, it has to run from the North Pole and meet right at the South Pole. You have another one to complete that. You can have another one originating from the North Pole all the way to the South Pole, etc. So longitudes run from the North Pole to the South Pole. North Pole to the South Pole. In the case of the latitudes, they run from west to east. So we're going to have these lines again running parallel to the equator. So running from west to east. But in this case, they do not meet either the west or the east. You have another one here. You can have another one here. And another one here, etc. So these which run from west to east, we call them the latitudes. These which run from the North Pole to the South Pole are called longitudes. North Pole to South Pole are longitudes, west to east are latitudes. One thing that we need to know is that the equator and the prime meridian divide the earth into two equal parts. In fact, all longitudes divide the earth into two equal parts. All longitudes divide the earth into two equal parts. And it is for this reason all longitudes divide the earth into two equal parts. It is for this reason that the longitudes are called great circles. We will discuss that in details later. And therefore called great circles. So when I talk about a great circle, I am talking about the longitudes. Great circle, longitudes. Let's see about what happens in the case of the latitudes. In this case, it is only the equator that divides the earth into two equal parts. Of all the latitudes running from west to east, it is only the equator that divides the earth into two equal parts. Only the equator, which is or let us put it this way, latitudes do not divide the Earth into two equal parts apart from the equator. So the latitudes, all these latitudes apart from the equator, all these latitudes apart from the equator do not divide the Earth into two equal parts. All the latitudes do not divide the Earth into two equal parts. And in that case, therefore, since they do not divide the Earth into two equal parts, they are referred to as small circles. So latitudes are called small circles. And since we've said that the equator is the only latitudes that divide the Earth into two equal parts, we can therefore conclude and say that the equator is the only small circle, or rather is the only latitudes that divides the Earth, or that is a great circle. That is a great circle. Why? Because it divides the Earth into two equal parts. Let me take that again. Since the equator divides the Earth into two equal parts, and in the case of the longitudes, we said all the longitudes divide the Earth into two equal parts, and that is why they are called the great circles. We can therefore conclude and say that the equator is the only latitude that is a great circle. Why? Because it divides the Earth into two equal parts. You can capture that. The equator is the only latitude that is a great circle, because it divides the Earth into two equal parts. So that is it. The equator is the only latitude that is a great circle because it divides the Earth into two equal parts. That is what we need to know in the bit of the introduction: the latitudes and the longitudes, the equator and the prime meridian. But a lot of attention should be drawn to the equator, which is a great circle. It is a latitude but a great circle. All the other latitudes are small circles. And with that, we can now proceed on to something else, and that is the position of a place. So the position of a place on the surface of the Earth, or rather on the Earth's surface. So if you have this as your globe, and you make it better, so, and this is the prime meridian, and that is the equator. The prime meridian and the equator are both 0 degrees. 0 degrees. Remember, this is the North Pole, and this is the South Pole, this is West, this is East. So the position of a place is basically used to locate a place, say, for example, London. Where is London located on the surface of the Earth? So you will want to know the longitude of London and the latitude of London. That is the position of a place. One thing that we need to know is that the position of a place is given in terms of longitude and latitude in coordinate form. That is very important. For you to give the place, you must give the longitude and the latitude in that order. So you would want to say it is the longitude is running from north to south, but you will see exactly what that implies. Let's say, for example, you have a town say at this point, and you're told that the longitude, or this longitude, is it is to the western side, so we can talk about maybe 40 degrees west, and this latitude is to the northern side, or the northern part of the equator. This one is to the western part of the prime meridian, and it is to the northern part of the equator. This is the equator. It is to the northern part of the equator, so give it maybe 20 degrees north. So you notice that the latitude of that town is intersecting at a point where the latitude is 20 degrees and where the longitude is 40 degrees west. So if you want to give the position of that place, you can say the position of this town, let's say that is London, is going to be longitude 40 degrees west and latitude 20 degrees north. You must give in that order, starting with the longitude followed by the latitude, and that is how you give the position of a place. Let's take another example here and say this one is to the eastern side. Give it 40 degrees east. You notice that it originates from the same point as the other one, so 40 degrees east, and give this one as 10 degrees south, which is the southern part of the equator. So the position of, say, a town here, let's say Nairobi, the position of that place will be, start with the longitude. The longitude is 40 degrees east, so 40 degrees east, and the latitude, southern part of the equator, 10 degrees south, so 10 degrees south. That is the position of that town, Nairobi. That is the position of that town, and that is basically what we need to know. Now, the one thing that I must mention and is that longitudes are measured from the prime meridian. Longitudes are measured from the prime meridian, and two, latitudes are measured from the equator. Longitudes are measured from the prime meridian. Latitudes are measured from the equator. Let's see what that exactly means. I will not use this one. Let me use lines to make it clearer for all of us to clearly understand what that means. Recall that this was the position of London from the globe, and this was the position of Nairobi from the globe. Just a reminder, longitudes are measured from the prime meridian, latitudes are measured from the equator. Now, I want to use lines, and I will encourage you to always use lines. Don't draw the globe. That one will be quite complicated. So if this is the prime meridian, north, south, and this is the equator, west, east. So the position of London is 40 degrees west, so it's on the western side. So 40 degrees west. Remember, we said that the prime meridian, this is 0 degrees, the equator, this is also 0 degrees. So what you do, you want to get 40 degrees. So you're going to measure from the prime meridian, moving in this direction, 40 degrees. And for the latitude, which is 20 degrees north, you're going to measure from the prime meridian. No, from the equator, sorry, from the equator. So from the equator, you know how to place your protractor, but you will not measure anyway. But this is important when we get to distance, when you will be required to get the angle subtending maybe a certain arc length. So you will need to know that you measure from the equator. That is 20 degrees north. So 20 degrees, you have the line there. So for the latitude, you measure from the equator. For the longitude, you measure from the prime meridian, moving in that direction. Latitude, you measure from the prime meridian. If it is north, you measure in that direction. If it is south, like in the second case, you have 40 degrees east. East is on this side, so you measure from this part, moving in that direction, and you get 40 degrees east. Then for 10 degrees south, you again start from the prime meridian, but moving in this direction. This is 10 degrees south. So we have the town here. This is Nairobi. Then we have the other town here. That is London. And that is basically how we measure, we locate the position of a place. You know how to locate, but the most important thing that I want us to focus on here is that longitudes are measured from the prime meridian. So it's 40 degrees west from the prime meridian, moving in this direction. 40 degrees east for Nairobi, prime meridian, moving in that direction, 40 degrees. Latitude, you measure from the equator. So for 20 degrees north from the equator, north, 10 degrees south from the equator, in the southern direction, southwards. And that is how you locate the position of a place on the Earth's surface. That is all about the position of a place. And with that, we can now focus on one of the most important parts of this topic. This is not to say that this is not important. It is important because this is what we will use in the next part of this topic. So the next part is distance. So you want to calculate the distance between 2 points. Now, what we need to know is that this distance can be obtained in two ways. We have one, when you're talking about a long distance along great circles. And two, distance along small circles. Distance along small circles. Now, recall that distance, well, we forget about distance first. Great circle is movement along the longitudes. Great circle, longitudes. Small circles, latitudes. The only exemption in a great circles is when you're moving along the equator, because the equator is the only latitude which is a great circle. So when you're moving along a great circle, you need to know that you're moving along a longitude, a circle of longitudes. And also the equator, just to mention that, very important. It is the only latitude which is a great circle. When you're moving along the small circles, you're moving along the latitudes. Distance along a circle of latitude. That is when we're talking about the small circle. Now the other thing we need to know is that this distance can be obtained in A, kilometers, and B, which might be a bit new, in nautical miles. nautical miles. It is denoted as NM, nautical miles. The same thing, you can get a distance in kilometers and also in nautical miles. In nautical miles. So one thing that is going to be very important here and you will need to recall is the formula. How do we get a distance along the great circle in kilometers? And how do we get the same distance along the great circle or circle of longitude in nautical miles? If you have these are they've just said we are going to use line to represent that, and I want to pick two towns. And the latitude is the same. So recall that I said latitudes are measured from the equator. So I have measured 40 degrees here because latitudes are measured from the equator, and also on this other side because they are along the same latitude, so I will still measure 40 degrees here. So if you're moving along a circle of longitude, remember we said from our globe is that if this is a prime meridian and you have a long, let me draw a bigger one. If that is a globe, you have the prime meridian here. So if you are to draw another longitude, then they're going to meet at the North Pole. So which means if I am moving from say a point at this point to this point through the North Pole, that means I will be moving along a circle of longitude. So if I'm told to move from this point A to B through the North Pole here, then I will be moving along a circle of longitude. You notice that I am moving along this longitude here. I am moving along that longitude. So you will be required therefore to figure out what is the size of that angle. From your knowledge of angles and plane figures, you notice that this is a straight line, and we know angles on a straight line add up to 180 degrees. So if this is 40 plus 40, that is 80, so I am left with 100 degrees. So, and what you will also need to realize here is that this is basically a sector. We have formed a sector. This being our center, the center of the earth, we formed a sector, and this is from the center of the earth to one of the surfaces. If this is the center of the earth, then you're moving all the way, and assuming we draw the equator here, this is the equator, this is the prime meridian, this is 40 degrees, this is 40 degrees. So you're moving from the center of the earth to one of the surfaces on the surface of the earth, or to a point on the surface of the earth, which means therefore that from this point, the center, to this point, that becomes the radius of the earth, NB. The radius of the earth is equivalent to 6370 kilometers. That is something you need to know, but in most cases, in fact in all cases, you will be given that, the radius, 6370. But you're given a different one, say for example 6371, because that is the other possibility. You must use what you are given, not what I have given there, but this is basically the radius of the earth. Back to what we were doing here, you notice that this is a sector. So if you want to get the distance between A and B, you are basically getting the arc length. Again, notice that if you're moving from A to B through the North Pole, then you're moving along a circle of longitude, which is a great circle. Now, how do we find arc length? Arc length is given by, it's the same as circumference, only that we have the angle here. So arc length is given by beta over 360 2 pi r, whereby r is the radius of the earth, and that means therefore that for us to get a distance along a great circle or a circle of longitude in kilometers, we use the formula beta over 360 2 pi r. Beta over 360 2 pi r. This gives us the distance in kilometers. I will only modify that formula from here going forward. So in the case of the distance in nautical miles, the formula is the same. Beta over 360 2 pi r. No, sorry, it's not the same. It's 60 beta, 60 beta. Now we will need to see what is beta. Beta in this case is the latitude difference. This is called the latitude difference. See, we are considering the latitude. 40 degrees north, 40 degrees north. The angle at the center here is 100 degrees. So beta is the latitude difference. Beta is the latitude difference. How about distance along a small circle? So if you are just told to move A to B along a parallel of latitude, I repeat that, distance between A and B along a parallel of latitude. In that case, you're told to move along a circle of latitude or a small circle, parallel of latitude, small circle, or along a small circle, which is one and the same thing. So how do you find that distance? Now this is why I'm only going to modify that formula. We will see how that is applied. So beta over 360 kilometers, 2 pi r. Now cos alpha. Cos alpha. And in nautical miles, we're going to have 60 beta cos alpha. So you notice they are the same. Only that in this case we're introducing cos alpha. Now what is the beta in this case? In a great circle, beta is the latitude difference. In a small circle, beta is the longitude difference. And alpha is the latitude. Alpha is the latitude. So when I divided into two, we have the great circle, we have the small circle, we have the formula for the two. Now what is this we are calling the longitude difference? Now let's look at it this way. We want to move from A to B through a circle of latitude, a small circle. And we say that longitudes are measured from the prime meridian. So from the prime meridian, we have 20 degrees on this side, we have 30 degrees on the other side. So I can sum it generally as such that for you to get the latitude difference, but this is an exemption in this case, I will demonstrate what that really means in some examples we're going to do. In getting the beta, the latitude difference, if let's say we have a term C, 20 degrees east and 30 degrees north. We have B, 20 degrees east and 10 degrees south. If you were to get the latitude difference in this case, maybe I can just sketch it here, very small one. We have 20 degrees east, so it's on this side. 20 degrees east for the longitude, 30 degrees north. 30 degrees north. We also have 10 degrees south. 10 degrees south. So if you want to get a distance along a circle of latitude, small circle, then you will need, not small circle but great circle, you will need to get the latitude difference in this case, great circle. So you notice that we say in latitude I measure from the equator, so this is the equator 0. So I measure 30 degrees north and 10 degrees south. So for us to get the angle subtending these points, let's say point, not say, but that's actually point C and D. The angle subtending the 2 points is the summation, because this is 30 degrees, this is 10 degrees. So the angle subtending the 2 is 30 plus 10, which is 40 degrees. So in this case, the latitude difference is equals to 40 degrees. You add the 2. And remember, in this case, you're moving along a circle of longitude from C to D. That is along a longitude, so it's along a great circle. So if you're moving along a great circle, you use beta, which is the latitude difference. And in this case, it is the summation of the 2. So you notice that one is due north, another one is due south. Northern hemisphere, 30 degrees north. Southern hemisphere, 10 degrees south, 10 degrees south. So if they're in different hemispheres, we add. Different hemispheres, we add. Let's see what happens if they are in the same hemisphere. And I want to change this to say 10 degrees north. So let's see how that is going to look like in the diagram. Again, draw it here. We have the longitude, which is 20 degrees east. Then we lower the equator a little bit because we will not require the lower side. So you have the equator there, which is 0 degrees. Then we have the first one, 30 degrees north. We can have it as high as possible. 30 degrees north. Then we have this one, which is 10 degrees south. No, not south, but north. It is in the northern hemisphere, but 10 degrees north. So it's definitely going to be lower than this. 10 degrees north. Now, the latitudes are measured from the prime meridian, so from the equator. So I measure the first one. The first one is 30 degrees. The second one here is here, which is 10 degrees. So this is the bigger one, from this line all the way mpaka hapa 30 degrees. This one mpaka hapa 10 degrees. So you notice the angle subtending C and D in this case is here. So how do we get that angle? So the bigger one, the two angles are overlapping in this case. We have 30 and 10. The two angles are overlapping. So I want us to get this angle here. So what we do? Check the bigger, so it's obvious here that should we check the bigger 30 minus 10. 30 minus 10 give us 20 degrees. So in this case, the latitude difference is 20. The latitude difference is 20. So we can therefore conclude and say latitude difference difference so when the latitudes are in the same let's start with the different, because that is what we started with, are in different hemispheres, we add. And we can have a demonstration of that. Yeah, you have already captured the formulas, so let's see what this exactly means. So we have C 20 degrees east and 40 or 30 degrees north, and D 20 degrees east and 10 degrees south. So if you have such, we can represent it this way, whereby we have these two lines, the equator and the prime meridian. We have 20 degrees east, so it's on this side, 20 degrees east. We have the first latitude, 30 degrees north. The other latitude is 10 degrees south, so it's on the southern side. So this one will be measure from the equator, 30 degrees, 10 degrees. So you notice the angles of tending C and D, in that case is going to be 40. 2. Latitude difference. So and just indicate as number 2. When the latitudes latitude are in the same hemisphere. Forgot that, in the same hemisphere, and the latitudes are in, no, this is not the same, but are in different hemispheres, north, south, where are in the same. Same hemisphere, we subtract. So let's see what that means. So let's again have maybe E, town E, 20 degrees east and 30 degrees north, and F, 20 degrees east and 10 degrees north. Same hemisphere for the latitudes. So let's see what happens in this case. We can draw again. You have the prime meridian here, 0 degrees, 0 degrees. This is the longitude, which is 20 degrees east. The latitude for the first town, E, is 30 degrees north. That is town E. Then town F here is 10 degrees north. So let us get this one clearly. So you have F there. So latitudes measure from the equator. So you have the equator, measure 30 degrees. Then you have the other town here, 10 degrees. So you notice in this case 30 degrees for the town E is overlapping with 10 degrees for town F. So in that case, therefore, the angles attending this arc line EF is going to be 30 minus 10, which gives us 20. That is what we are saying. When they are in different hemispheres, we add. When they are in the same hemisphere, we subtract. Remember, this is the same for the longitude. This is the same for the longitude. Maybe you can see exactly what happens in the case of the longitude. Maybe just use one example, but it is the same. In fact, we can use the longitude, latitude stroke longitude. Stroke longitude. Where is it? The other one we have here, longitude. Just include that because it is one and the same thing. Maybe just do one example and see how that one works. So we have two towns. That is now when you're moving along a small circle. Remember, when you're moving along a small circle, you need the longitude difference. So let's see. You have two towns. A, give it 10 degrees east and 10 degrees and give it 20 degrees north, and B 20 degrees west, and 20 degrees north. So if you're moving along a circle of latitude, small circle, you notice when you're moving along a circle of latitude, this one remains the same. But that is not always the case, but in most cases you'll be given these as being the same. So you're told to find the distance between A and B. A and B along a circle of latitude, or rather small circle. So you must recall the formula, let's say in kilometers. So you need beta over 360, 2 pi r cos alpha. Beta here in a small circle is the longitude difference, and alpha is basically the latitude, and the latitude in this case is 20. That is why it has to be the same. So we need to get the longitude difference. Now we said in getting the longitude of the latitude difference, just check if they are in different hemispheres, you add. Same hemisphere, you subtract. So in this case, this is 10 degrees east, 20 degrees west. So in that case, we're going to have 10. They are in different east, west, different hemispheres. So it's 10. So beta is equals to 10 plus 20. We have 30 degrees. Beta, so 30 over 360 times 2 times 22 over 7 times r. R is the radius of the earth. And I have just said the radius of the earth is 6370. So times 6370 times cos alpha. Alpha is the latitude, and the latitude is 20, so it's cos 20. You just get the answer. If you're told to find that distance in nautical miles, that is along a small circle, that will be 60 beta cos alpha. You already have beta as the longitude difference. So that is going to be 60 times beta, which is 30, times cos alpha, which is 20. You get the answer in nautical miles. And that is it. So that is how you find the longitude difference and the latitude difference. Just recall that distance along a great circle, the formula, the distance along a small circle, the formula. But for each one of them, in fact, let me summarize them here. The formulas and what each one of them means. Just a summary, maybe you can just represent them on a table. Say, so distance we have in kilometers and in nautical miles. So in kilometers we have a small circle. So we introduce another one here, a small circle. So we have the first one, great circle in kilometers. We must recall beta over 360, 2 pi r. So beta over 360, 2 pi r. R is the radius of the earth. In nautical miles, 60 beta. R beta. R is the radius of the earth. And beta is the long latitude difference. Remember, when you move along a great circle, you're moving along a circle of longitude. Small circle, the same, beta over 360, 2 pi r, but introduce cos alpha. Nautical miles, 60 beta, cos alpha. Again, r is the radius of the earth. Theta in this case, small circle, is the longitude difference. Longitude difference. And what else? Alpha is the latitude. Is the latitude. So you notice when you're moving along a small circle, in most cases, the latitudes for the 2 points or towns will be the same. When you're moving along a great circle, the longitudes of the 2 towns will also be the same. That is something that you might need to take note of, but not in all cases. In most cases, they will be the same. So do not crucify me next time when I give you one whereby you're supposed to get a distance along a great circle, but the longitudes of the 2 towns are not the same. It doesn't have to be the same, but in most cases, it is always going to be the same. And with that, that is what we need to know in as far as distance is concerned. NB, before we leave the subtopic of distance, NB. When you're told to find the shortest distance, find the shortest distance between A and B, C and D, etc. Find the shortest distance. Anytime the question is about shortest distance, that is the distance along a great circle. Shortest distance is the distance along a great circle or along a circle of longitude. So, shortest distance is the distance along a circle of longitude, or simply great circle. Or simply great circle. That's it. Shortest distance. Find the shortest distance. It is a distance along a great circle or a small circle. And that is it for distance. And now the last part of this topic. Time, or simply local time. And I want to modify it to longitude and time. If you're given 2 towns, say A, 20 degrees east and 40 degrees north, and B, 20 degrees east and 30 degrees south. These 2 towns lie along the same longitude, 20 east, 20 east. If 2 towns lie along the same longitude, they have the same local time. Let me just mention, the local time in Nairobi is not the same as the time in, say, Washington. Why? Because Nairobi and Washington DC lie along different longitudes. The latitudes can be the same, but that does not dictate time. That is why I am focusing on longitude. So if 2 towns are along the same longitude, then the time in the 2 towns will be the same at any given time. So for example, if it is 7:00 a.m. in town A, then it has to be 7:00 a.m. in town B. It has to be. Why? Because they are along the same longitude. 20 east, 20 east. So if they are along the same longitude, the time, the local time, and in this case the local time, is going to be the same. It is going to be the same. But if they are in different longitudes, let's say for example C, 40 degrees west and 20 degrees south, and D, 40 degrees east and let's say 20 degrees south. The latitudes are the same. So let's say the time in this town is 9:30 p.m. You will need to figure out what is the time in town D. One thing, let's draw and see. One thing that but before we even draw, notice that this is 40 west, 40 east. They are in different longitudes. So we've got to draw that. We're going to have the first town being 40 degrees west. 40 degrees west. And the other town is 40 degrees east. So you notice they are in different longitudes. So if they are in different longitudes, their time is going to be different. Before we even focus on which one is ahead in time, you need to know how then do we know the time difference. How do we know the time difference? The longitude difference gives the time difference. So you need to recall, how do we get the longitude difference? So the first thing you need to know, if they are in different longitudes, then find, to get the time difference, you need to get the longitude difference. 40 west, 40 east. Remember, we said if they are in different hemispheres, we add. If they are in the same, we subtract. So this is 40 west, this is 40 east. Different, you add. So longitude difference will be 40 degrees plus 40 degrees. You get 80 degrees. That is the longitude difference. So if having the longitude difference, you now proceed on to getting the time difference. You will need to recall this relationship. So NB, 1 degree is equivalent to 4 minutes. 1 degree is equivalent to 4 minutes. So if that is the case, so 1 degree is equals to 4 minutes. That is how you denote time. I think you remember that in Form 2, Neka 2 prime. They indicate 4 minutes. What about 8 degrees? So that is 80 times 4. It gives us 320. So that is 320 minutes. The time difference is 320 minutes. So you need to change that. Maybe you can change that to hours. So that will be 360, 320, sorry, divided by 60 to change to hours. So you have 2, 3, 2, 16. You have 16 divided by 3. That is going to be 3, no, not 3 but 4. 4 and 12, is it 3 over 4? Is 4, 12, 4. So 4 and 3 over 4 hours. So the time difference is 4 and 3 over 4 hours. So, but you need to figure out which one is ahead in time. The time in town C, 40 degrees west, is 9:30 a.m. p.m. So this is what you need to know. If a town is due east, is to the east of the other one, then it is ahead in time. If it is to the west, then it is behind in time. So from this point, in this direction, behind. So if you're given the 9:30 towards the direction, to get any other time for a town on this side, behind means subtract. Any other town that is on this side, it is ahead, so you add. So in that case, you notice this one is in this side, to the eastern side. If it is to the eastern side, then it is ahead in time, so you add. So the local time for town B will be 9:30 plus for 4 and 3 over 4. 3 over 4, that is the same as 45 minutes. So 4 and 45 minutes. 75, that will be 15. 13, that is 14. So 14, 15 hours. 14, 15, and from 9:30, that is basically the same as 2 p.m. because you're adding 4 hours. AM, I mean, because this was p.m. So this will be 14, 15 minus 12, that is 2:15 a.m. You need to be very careful with this one. You're adding 4 hours. 9 for 4 hours, that is 14, 15 a.m. And that is what we need to know in that case. It is ahead in time. So the first thing you need to figure out is the longitude difference. So in this case you cannot get because they are in the same longitude, so the time will be the same. But for this one, the longitude for the first town is 40 west, the longitude of the other one is 40 east. So they are in different longitudes. So the time will be different. Local time, I mean. So when it is 9:30 in this town, it cannot be 9:30 on the other town because they're in different longitudes. So in that case, you need to find out what is the longitude difference between the two towns. Remember, we said if they are in different hemispheres, we add. If they are in the same, you subtract. So in this case, this is 40 west, 40 east. So we add 40 plus 40, get 80. I have given this relationship here. Thereby we're saying 1 degree is the same as 40 minutes. And I know you know that from your knowledge in geography and maybe social studies, primary school. So we have 1 degree is equals to 4 minutes. What about our longitude difference? Because that should give us the time difference. And that has given us 320 minutes. So 320 minutes changed to hours, you have 4 and 3 over 4. But that is not enough. We will now need to find out which one is ahead in time, which one is behind in time. And I have said if a town is to the east of your point of reference, in this case town C, here, if it is to the east, it is ahead in time. If it is to the west, then it is behind in time. But in this case, it is to the east. It is to the east, so it is ahead in time. So what we do, you add. If it is to the west, you subtract the time difference to get the local time of the other town. And with that, you should be able to do any question related to this. You can as well, let's say for example, maybe you can introduce one more before we call it a day. Let's see another town. Call it A. And I want to give it the coordinates. 50 degrees west and 10 degrees north. And we have another one, B. We have 30 degrees west and 10 degrees north. So you notice the two towns are, and I want to give these local time, 10:00 a.m. So if you are to do this, zero, zero. So I have the first town A. $50 degrees west, 50 degrees west, 10 degrees north. So that town is here. We have the other town 30 degrees west, 30 degrees west, and still 10 degrees north. They are the same, they are along the same latitude. So the longitude difference in this case will be they are in the same hemisphere, west. So the longitude difference will be 50 minus 30, because if they are in the same hemisphere, you subtract. So the longitude difference is 20. Now let us find the time difference. We said 1 degree is equals to 4 minutes. What about 20 degrees? So that will be 20 times 4. That gives us 80 minutes, not degrees. 80 minutes. 80 minutes is the same as 1 hour and 20 minutes. 1 hour, 20 minutes. Now let's see which one is ahead in time. Now we are given the local time of B. The local time of B, A and B. We are given the local time of B, 10:00 a.m. We have the local time of B. Notice that A is to the western part of B, to the west. It is due west. So if it is due west, then it is behind in time. So behind in time means you subtract. So we take 10 a.m. minus 1 hour 20 minutes. So you have 60, that will give us 40 and 9 we have 8. So the local time of the other town is 8:40 a.m. It is behind the time because it is to the western part. And that is all about that topic. You need to understand those key areas, position of a place, distance along the great circle, distance along the small circle in kilometers and in nautical miles, and you have and now longitude and time difference. One thing that you will need to recall, maybe you might come across that, is speed. Speed does not change, it is distance over time. Distance over time. So the only thing you need to know is if the distance is in nautical miles. If the distance is in nautical miles, the speed is given in something called knots. Remember, this is very common, but especially when you're talking about aeroplanes. And remember, in this case, your position of a place on the Earth's surface. You're moving from Nairobi to Washington to London, it is DC. Those are very long distances, so you must get a distance in nautical miles. And in that case, but the time is in hours, it doesn't change. So you have the distance in nautical miles, divide by time in hours, you get your speed in knots. Take note of that, in knots. So that is very, very important. You must remember that. So don't be scared when you come across knots. It is one and the same thing. You're only being told to find the distance in nautical miles, and you already have the formula for doing that. And with that, you should be able to do any question in this topic. And that marks the end of this topic. As usual, just use your book, solving problems. You have the guide, get as many questions as possible in this area, figure out what you can do, what you cannot do in this case. Maybe in due course, you will be able to handle this together, anything that you might not be able to do or anything that you not understand in this topic. And with that, I want to wish you well as you continue practicing on this topic and equally on the other 4 topics. So far, we've covered this should be the 5th one. And we had already covered 1, so we still have around 3 or 4 to go, and we shall do them in due course. So with that, I wish you well as you practice on this topic.